Mars, the red planet, a celestial body that has captured the imagination of humanity for millennia. From ancient civilizations to modern scientists, Mars has always been a source of wonder and mystery. It has fascinated humans for centuries. Ancient astronomers meticulously charted its movements across the night sky, and early telescopes revealed its enigmatic surface features, sparking countless theories and stories. It's a cold, dry desert world much smaller than Earth. The Martian landscape is a stark contrast to our own, with vast deserts, towering volcanoes, and deep canyons that tell a story of a planet that was once geologically active. Mars is about half the size of our planet. Despite its smaller size, it has a land area roughly equivalent to all of Earth's continents combined, offering a vast expanse for exploration and potential future habitation. It has a very thin atmosphere, mostly carbon dioxide. This thin atmosphere means that the surface pressure is less than 1% of Earth's, making it a challenging environment for human survival without significant technological assistance. The surface of Mars is a rusty red color. This distinctive hue is due to iron oxide or rust, which covers much of the planet's surface, giving it its nickname, the Red Planet. You can see volcanoes, canyons, and plains. Olympus Mons, the largest volcano in the solar system, and Valles Marineris, a canyon system that dwarfs the Grand Canyon, are just a few of the remarkable geological features found on Mars. It's a harsh and unforgiving environment, but it holds the promise of something extraordinary. The extreme conditions, including frequent dust storms and temperatures that can plummet to -80 degrees Fahrenheit, present significant challenges, but also opportunities for scientific discovery. Mars is the planet most like Earth in our solar system. Its day length, axial tilt, and seasonal cycles are remarkably similar to our own, making it a prime candidate for studying planetary processes and the potential for life. This makes it a prime candidate for future exploration and even colonization. With advancements in technology, the dream of sending humans to Mars is becoming more feasible, and plans for manned missions are already underway. Imagine humans walking on Mars. The first footprints on the Martian surface will mark a new era in space exploration, symbolizing humanity's ability to reach beyond our home planet and explore new worlds. It could happen in our lifetime. The timeline for Mars missions is accelerating, with ambitious goals set by space agencies and private companies alike, aiming to establish a human presence on Mars within the next few decades. But before we pack our bags, we need to understand what we're getting ourselves into. Preparing for a journey to Mars involves rigorous training, extensive research, and overcoming numerous technical and logistical challenges. We need to learn everything we can about this alien world, from its climate and geology to the potential for past or present life. Every piece of information is crucial for planning successful missions and ensuring the safety of future explorers. That's what this essay is all about. Join us as we delve into the mysteries of Mars, exploring its past, present, and future, and uncovering what it will take to make humanity's dream of reaching the Red Planet a reality. If you look at Mars in the night sky, you'll notice its distinctive red hue. This striking color has fascinated humans for centuries, earning Mars the nickname, the Red Planet. But what exactly gives Mars its unique coloration? But why is Mars red? The answer isn't just skin deep, it goes much deeper into the planet's geological history. The answer lies in its geology. Mars is covered in iron oxide. We call this rust. This iron oxide forms a fine dust that coats the entire surface of the planet. Imagine leaving your bike out in the rain. It will start to rust. This is because the iron in the metal reacts with oxygen and water, forming iron oxide. The same process has occurred on Mars, but on a planetary scale. The same thing happened on Mars, but on a much larger scale. Over millions of years, the iron in the Martian soil reacted with trace amounts of oxygen and water, creating the rust that gives Mars its red color. Billions of years ago, Mars had a lot of water. Rivers, lakes, and perhaps even oceans covered its surface. This water played a crucial role in the rusting process. This water reacted with the iron on its surface. The interaction between water and iron led to the formation of iron oxide, or rust. The result? Rust, which gives Mars its famous red color. This rust is not just on the surface. It permeates the soil and rocks, creating a pervasive reddish hue. This rusty dust covers almost the entire planet. Martian winds whip up this dust into massive storms that can engulf the entire planet, spreading the red color far and wide. It's a reminder of Mars's watery past. These geological formations and the presence of iron oxide tell a story of a planet that was once very different from the dry, dusty world we see today. It's also a clue that Mars might have once been a very different place. Understanding why Mars is red helps scientists piece together the planet's history and its potential for having once supported life. Water is essential for life as we know it. The good news is that we've found evidence of water on Mars. This is a big deal for several reasons. First, it suggests that Mars might have once been habitable. Imagine a time when Mars had oceans and rivers. Could life have existed there? Second, the presence of water makes it easier for humans to colonize Mars in the future. We need water to drink, grow food, and produce rocket fuel. The evidence for water on Mars comes in many forms. There's ice at the poles, and we found evidence of ancient rivers and lakes. Some scientists believe there might even be liquid water underground. The biggest question of all is there life on Mars? We haven't found any aliens yet, but there are some promising signs. For example, we've detected methane in the Martian atmosphere. Methane can be produced by living organisms. This doesn't mean there's life on Mars, but it's a tantalizing clue. Right now, rovers like Curiosity and Perseverance are exploring Mars. They're looking for signs of past or present life. They're analyzing rocks and soil for organic molecules. Finding evidence of life on Mars would be one of the most significant discoveries in human history. It would mean we are not alone in the universe. Section 5. Exploring the Red Planet, a history of Mars missions. Humans have been dreaming of going to Mars for a long time. The Red Planet has always fascinated us with its mysterious surface and potential for life. From ancient astronomers who gazed at Mars through rudimentary telescopes to modern scientists who study it with advanced technology, our curiosity about Mars has never waned. We've been sending spacecraft to Mars for over 50 years. These missions have been a testament to human ingenuity and our relentless pursuit of knowledge. Each launch represents a giant leap in our understanding of the cosmos and our place within it. The first successful mission to Mars was Mariner 4 in 1965. This groundbreaking mission marked the beginning of a new era in space exploration. It was the first time humanity had reached out and touched another planet, setting the stage for all future Mars missions. It sent back the first close-up pictures of the Martian surface. These images revealed a barren, cratered landscape, challenging our previous assumptions about the planet. The data collected by Mariner 4 provided invaluable insights and spurred further interest in Mars exploration. Since then, we've sent orbiters, landers, and rovers. Each type of mission has its own unique objectives and challenges. Orbiters map the planet from above, landers study specific locations, and rovers traverse the surface, conducting experiments and sending back detailed information. Each mission has taught us more about Mars. We've learned about its weather patterns, surface conditions, and even detected signs of water. These discoveries have been crucial in shaping our understanding of Mars and its potential to support life. We've learned about its atmosphere, its geology, and its potential for life. The thin atmosphere, composed mostly of carbon dioxide, presents challenges for future human missions. However, the discovery of ancient riverbeds and minerals that form in water suggests that Mars may have once harbored life. Every mission brings us one step closer to sending humans to Mars. Astronauts are already training for the challenges they will face, from the long journey to the harsh conditions on the Martian surface. These preparations are essential for the success of future manned missions. The next few decades will be an exciting time for Mars exploration. With advancements in technology and international collaboration, we are on the brink of achieving what once seemed impossible. The dream of setting foot on Mars is becoming a reality. We have ambitious plans to send humans to Mars in the 2030s or 40s. These missions will not only expand our scientific knowledge but also inspire future generations to continue exploring the final frontier. The journey to Mars is just beginning, and the possibilities are endless. Section 6. Colonizing Mars. A dream or a possibility? The idea of colonizing Mars might seem like science fiction, but it's closer to reality than you might think. Several organizations are working on plans to establish a permanent human presence on Mars. Why colonize Mars? There are many reasons. First, it would be a backup plan for humanity. If something catastrophic happened to Earth, we'd have a second home. Second, Mars could teach us more about our own planet. By studying Mars, we can learn about the evolution of planets and the origins of life itself. Third, Mars represents the spirit of exploration. Humans have always been driven to explore new frontiers. Mars is the next great challenge. Section 7. Why Mars Matters, the Future of Humanity. Exploring and colonizing Mars isn't just about science and adventure, it's about the future of humanity. As our population grows and resources dwindle, we need to think about expanding beyond Earth. Mars is a challenging environment, but it's also full of potential. It has resources that we can use, such as water ice and minerals. With the right technology, we could transform Mars into a second home for humanity. By pushing the boundaries of science and technology, we can create a better future for ourselves and for generations to come. Mars is not just a destination, it's a symbol of our potential as a species. Section 8. Challenges and Solutions. Overcoming the obstacles. Colonizing Mars won't be easy. We face many challenges, such as the thin atmosphere, radiation exposure, and the lack of readily available resources. But for every challenge, there's a solution. We can create artificial environments, develop radiation shielding, and find ways to extract resources from the Martian soil. We're already developing the technology we need. We have 3D printing for building structures. We have hydroponics for growing food, and we have innovative ideas for generating energy. The journey to Mars will be long and difficult, but the rewards will be worth it. Section 9. Conclusion: A Martian Future. Imagine a future where humans live and work on Mars. Children are born on Mars, and they look up at the night sky and see Earth as a distant blue marble. This might seem like a distant dream, but remember, people once thought flying was impossible. They thought landing on the moon was impossible. Yet we achieved those dreams through hard work, innovation, and a spirit of exploration. Mars is the next giant leap for humanity. It's a chance to create a new chapter in human history. It's a chance to inspire future generations. It's a chance to build a better future for all of us. Let's make it happen.